Let's go over long division, starting with division algorithm. So division algorithm is you have a dividend divided by divisor that is equals to quotient plus the remainder divided by divisor. So let's go over a very fundamental example. So let's say we have 7 divided by 2. So 7 divided by 2, that is equals to 3.5, right? So you use a 3. 3 times 2 is equals to 6, so the remainder is equals to 1. So how do you express that, write that using division algorithm? So here is how you have the dividend divided by divisor equals to quotient plus remainder over the divisor. So if you have a 6 divided by 2, that means the remainder is equals to 0. So this becomes a 0 divided by 2. So you have a 6 divided by 2 equals to 3. So in that case, there is no remainder. And then take a look. 3 plus 0.5 is equals to 3.5. So that is called division algorithm. We are going to put this long division on polynomial. So the first polynomial, you have x to the third minus 4x squared plus 20x minus 10 divided by x minus 3. So the way we do this is we have write x minus 3, and then we do that. We put the dividend in here, x to the third minus 4x squared plus 20x minus 10. X minus 3 has two terms, so we need the first two terms to start the first step. So the first number that goes up here is x squared. X squared times x is x to the third. X squared times minus 3 is minus 3x squared. Now, you might ask me, hey, do we have can we use something other than x squared? The answer is no, you cannot. Here is why. You are going to subtract these two lines. And then when you perform the subtraction, the first item must be gone. X to the third minus x to the third must be gone. If you use something other than x squared, you won't be able to get rid of the x to the third. So if this cannot be cancelled, that means this term is wrong. So you have, it is important to write the minus and the parenthesis. Let me explain why. So x to the third minus x to the third is 0. Everybody gets that right. But if you do not use this minus, the next step that you will just go negative 4 minus 3. If you don't use this minus to remind yourself. So therefore, it is extremely important to use a minus in here. So if one of this little step is wrong, the entire long division is wrong. So you have negative 4 minus 3. So that will be a negative 4 plus 3, which is equals to negative 1. So you have a negative x squared, pull another term down, plus 20x. And then the next term is minus x, so you have a minus x squared and then a plus 3x. And then that's it. Again, subtract the whole thing. You have a negative x minus itself gone. Negative 20 minus 3, that is equals to 17. Without this minus and the parenthesis, you will just go 20 plus 3. Minus 10, and then the last term is plus 17, 17x. 17 times negative 3 is equals to negative 51, and then you perform another subtraction. So you subtract the whole thing. That means you are doing negative 10 minus 51. If you don't write the minus, you will just go negative 10 minus 51. So this is negative 10 plus minus becomes a plus. So the remainder is equals to 41. And then you express the whole thing using division algorithm. So you have to write the whole line. I have a very limited of space. I will just ask you what to write first. So what you have to do is you copy this all over again. So you bring this piece, whatever I gave you, down here. And then you say that is equals to the quotient x to the second power minus x plus 17, and then you add the remainder divided by the divisor, which is x minus 3. If the remainder is negative 41, then you put a negative up there. And then you box this answer. This is your final answer. So this is how you report your answer of a division of a long division problem. The next problem in green, do you see that we have the 6th power, we have the 4th power, we have some missing power. The fifth power it is missing. the third power and the second powers, they are missing. We have the first power, we have the constant. How do we take care of the missing power? Here is how. So we match the color first. We write x minus 2, and then we do a long division, right? So we write 2x to the 6. The fifth power is missing, then we use a 0 plus 0 plus 0x to the fifth. That doesn't change the problem because 0 times x to the fifth is 0. I just add the 0 in there for my convenience. And then you have x plus 4, x to the fourth. And then the third degree and the second degree plus 0x to the third plus 0x squared. And then you have the first degree plus x minus 5. So now we have the 6, 5, 4, 3, 2, 1, and a constant. So I just add 3, 0. That doesn't change the problem. Can you just do it without adding the 0? Yes, you can do that, but it will be extremely easy to make a mistake. I tried that, not using 0. When I was a student, I ended up making a bunch of mistakes. So I just decided, fine, just add a few 0 to erase, just add a few 0 to make sure you earn the point for these problems. Okay, first term. We have to use a 2x to the fifth because that times x is 2x to the 6th, and then minus 4x to the fifth. All right, and then you draw a line, you subtract that. 2 minus 2 is gone, 0 minus 4, you have a plus 4x to the fifth. Pull another term down, and then you have a minus 4x to the third, right? That times x, fourth power, sorry. Fourth power. That times x gives you a 4x to the fifth, and then plus 8. Oh, this is a plus 2, huh? Wow, I was wrong the whole time. Okay, I'm glad that this is only the second line. I think all of you get this right except me. Okay, let's fix this. So this will be a plus 4, and then minus, this becomes a minus 4. And then I think that affects this. Does that affect the next one? So you have that. You have negative 4 times x. So that gives you, let me double check. Plus, minus, plus. Yep. So you have a negative 4 times x. So that gives you a negative 4x to the fifth. And then minus 8 x to the fourth. Subtract the whole thing. Negative 4 minus itself is gone. You have 1 minus 8. That becomes 1 plus 8, which is equals to 9. So 9x to the fourth. Pull another 0 down. And then the next term is a 9 plus 9x to the third, right? 9x to the third times x is 9x to the fourth. And then 9 times 2 is 18x to the third. Draw a line. Perform the subtraction. 9 minus 9 is gone. 0 minus 18 is negative 18. Negative 18x to the third. And then you pull the next 0 down. So the next term must be 18, right? Minus 18x squared times x is minus 18x to the third. And then we have a minus 36. 18 times 2, 36x squared. And then you subtract the whole thing. You perform a subtraction. 18 minus 18 gone. 0 plus 36. So you have a 36x squared. Pull the x down. And then the next term must be 36x. So plus 36x. You have a 36x squared. So 36x squared. 36 times 2, that is a 72. And then you subtract that. 1 minus 72 is a negative 71. So you have a negative 71x. Pull the last term down, 5. And then the last term must be minus 71. So you have a minus 71x. Minus 71 times 2, that will be minus 142. And then you subtract this. Negative 5 plus 142, that is 137, right? So the remainder is 137. So how do you express that using using division algorithm. So here is how you copy this again. So you copy this, you copy the given problem again, and you say whatever I gave you, that is equals to, you can't see the top, huh? So you have a 2x to the fifth minus 4x to the fourth plus 9x to the third minus 18x squared plus 36x minus 71. Did I copy everything right? Minus plus 9 minus 18, 36x minus 71. And then you plus the remainder divided by the divisor, which is x plus 2. What if the remainder is negative 171? Then simple, you put a negative there. But this case is positive. Let's don't mess that up. And then here is the answer that you have to report. Okay, box this, box that. Yep, perfect. All right, so moving on to the last problem. The last problem, we have a fifth power. The fourth power, the third power is missing. The first power is missing. Okay, we have x squared minus x plus 1. And then this, we have x to the fifth. Fourth power, third powers are all missing. So we have to add that. We have to plus the 0x to the 4 plus 0x to the third. And then we have the second degree. Minus 3x squared. The first degree is missing. And then we add 8 at the end. Oops, this color. So plus 0x squared. Okay, this one has 3 terms. Then we need the first 3 terms. So this must be x to the third. Because x to the third times x squared, that is equals to x to the fifth. And then minus x to the fourth plus x to the third. Draw a line. Ooh, we might be running out of space. Subtract that. What do we have? 0 minus minus 1. That is equals to 1. So we have x to the fourth minus x to the third minus 3x squared. And then the next term must be plus x squared, right? Because x squared times x squared is x to the fourth minus x to the third. And then plus x squared. All right. Draw a line. And then this is a minus, right? So minus the whole thing. So this time we have the first 2 terms are gone. So the first 2 terms are gone. So we might have to like put it down here. So we have negative 3 minus 1. So that is a negative 4x squared. Pull the square down. Where is the first power? Did I miss the first power? Oh, here. I said first power, right? But I wrote second power. So we have 5. 4, 3, 2, 1, and then constant. Okay. So this is the first power. And then plus 8. So the last one must be a minus 4, right? So minus 4. We have a negative 4x squared minus 4 times minus 1 plus 4x. And then minus 8. Final subtraction. So we have to subtract this. Okay, 0 minus 4 is negative 4. 8 minus minus 8, 4 or 8? 4, huh? 4. Why do I put an 8? 4. 8 plus 4, that is equals to 12. Alright, so that is my remainder. And then the answer is, what is the answer equals to? So we have space, so we have to do x to the fifth minus 3x squared plus 8 dividend divided by divisor. Minus x plus 1, that is equals to the quotient, x to the third plus x squared minus 4, and then we plus the remainder over the divisor, which is x squared minus x plus 1. And then this is called division algorithm, and you have to report this answer. Alright, so that is the end of this video. If you like the way I explain long division, give me a thumbs up, give my channel a subscribe. Truly appreciate your support, and I will meet you all in the next video for synthetic division. Signing out.